Assalamualaikum. Hi everyone. Let's continue our lesson regarding topic uniform circular motion. In previous lesson, subtopic 6.1, you already learned about uniform circular motion. That is a motion in circle with constant speed, but its direction of velocity is continually changing with time. You also been taught the related terms that we have used in this topic. In subtopic 6.2, we will learn about centripetal force. Through this lesson, you should be able to define centripetal acceleration and understand the role of centripetal force on an object that performing uniform circular motion. In uniform circular motion, the direction of the velocity changes constantly. So, there is always an associated acceleration even though the speed might be constant. Centripetal acceleration is defined as acceleration of an object moving in circular path whose direction is towards the center of the circular path and whose magnitude is equal to the square of speed divided by the radius. And it is written as AC equal to V square over R. I will show you the direction of this centripetal acceleration equation AC equal to V square over R later on. In previous lesson, you learned about relation of velocity that is equal to the radius times angular velocity, which is V equal to R omega. Since V equal to R omega, centripetal acceleration also can be written as AC equal to R omega square or AC equal to V omega. How about its direction? The direction is always pointing towards the center of the circle and always perpendicular to the linear velocity. This figure shows an object moving in circular path at a constant speed. The direction of instantaneous velocity is shown at 3 points along the path. Here, here, and here. We can say that the object moves in anti-clockwise direction. The velocity v is always tangent to the circle and perpendicular to the acceleration a. The acceleration a is always pointing towards the center of the circle. In uniform circular motion, an object moves at a constant speed has an acceleration. Why an object has centripetal acceleration? As object moves in circle with constant speed, its direction is continually changing with time. Let's consider these 2 points in this diagram. This point is initial point correspond to initial velocity, and this point is final point correspond to final velocity. An object moves in circle with radius r within time interval delta t from initial point to the final point and make a circular arc S or linear displacement delta S as well as angular displacement delta theta. Velocity being a vector quantity, it has a constant magnitude, but the direction is changing by the time. Thus, there is a change in velocity and acceleration occurs. Let's consider this triangle of velocity. Mathematically, the final velocity is a resultant vector of initial velocity and delta v. So v final equal to v initial plus delta v. Or it can be written as delta v equal to v final minus v initial. So delta v is called change in velocity that is directed toward the center of the circular path. Note that the speed v equal to the magnitude of initial velocity and also equal to the magnitude of final velocity. From the definition of velocity, which is rate of change of displacement, we know that delta s equal to v delta t and delta theta equal to s over r, which is equal to v delta t over r and approximately equal to delta v over v. To understand this, let's consider this triangle and this triangle. Delta S over R, delta V over V, the speed V here is the magnitude of both initial velocity and final velocity. So, since the acceleration is rate of change of velocity, hence, by rearranging this equation, the acceleration becomes v squared over r. And this acceleration is called centripetal acceleration. So, the equation of AC equal to v squared over r is proven. According to Newton's second law, an object that is accelerating must have net force acting on it. F net equal to summation of F equal to ma. Therefore, an object moving in a circle must have a force applied to it to keep it moving in that circle. That is, a net force is necessary to give its centripetal acceleration. Applying Newton's second law, summation of F equal to ma. Since in uniform circular motion, the only centripetal acceleration exists, so we can equalize the equation of net force summation of F equal to mac and also equal to mv squared over r. In previous lesson, we know that AC equal to v squared over r. This net force is in the same direction as centripetal acceleration, thus is known as centripetal force, Fc. Let's consider this triangle. The net force required to keep the object moving in a circle is always directed toward the center of the circle. And the net force causes a centripetal acceleration. So the direction of centripetal acceleration and centripetal force is the same. Both are directed towards the center of circle. Centripetal force is defined as net force acting on a body of mass m, causing it to move in circular path of radius r with constant speed v, in which the direction of centripetal force is towards the center of the circular path. Fc equal to summation of F equal to MAC, or can be written as Fc equal to mv squared over r. In the previous lesson, subtopic 6.1, you have already learned about relation between velocity and angular velocity. This is the linear velocity and this is the angular velocity. So from this relation, centripetal force also can be written in this form. Fc equal to mr omega square, or Fc equal to mv omega. The centripetal force is not a new kind of force. The term centripetal merely describes the direction of the net force is directed towards the center of the circular path. Any force or components that act along the radius towards or away from the center of the circle can contribute to the centripetal force. Look at an example here. A car that moving in circular path, the centripetal force is produced by the friction. Swinging a ball at the end of a string, the centripetal force is produced by the tension in a string. Moving of planets and moons in circular orbits, the centripetal force is produced by gravitational force. If there is no more centripetal force acting on the object, what will happen to the object? Let's consider this case. If the string is being cut or snaps, which means that the string breaks, centripetal force suddenly disappears. Then the circular motion stops and the object continues its motion in a straight path in the direction of v, which is tangential to the circle. Look at this figure. Is there any work done by centripetal force? Centripetal force is perpendicular or 90 degrees to the direction of object's velocity. No work is done by centripetal force Fc because no displacement in the direction of force, since the vector of velocity and vector of force is perpendicular to each other. So there is no work done by centripetal force. Hopefully this lesson will make you better understand about uniform circular motion. In the next lesson, I will share with you a problem-solving strategy regarding uniform circular motion. Thank you for watching.